Okay, we are looking into information retrieval concepts, and we started with term document indices matrix. Now, the name itself says that terms are the rows and documents are the columns. In our machine learning approach, we take documents as rows and terms as columns. In information retrieval, we take documents as columns and terms as rows because these are the document vectors, right? Document vectors, and we'll have a query vector. We'll try to multiply the document vector with query vector and try to find out a rank, right? So here it is a Boolean retrieval model. Here also we are doing we are actually multiplying the term vectors and trying to find which document has got whatever the maximum, the number like the one. But in our rank retrieval model based on TF-IDF or bag of words data, we'll take document vectors and multiply them and calculate rank. For that reason, we are representing documents as columns. Okay, and we have seen problems with the term document matrix, indices matrix, where it occupies a lot of space, and the query should be very appropriately framed. Right, inverted index is one solution to solve the space problem, but it still lacks in providing more sophistication to see where exactly and how many times a term occurred in a document. So that can be solved with positional indexing. Right? When we have positional indexing and we have this kind of skip connections, the search becomes easy. It becomes a little faster. We try to look at these concepts because the data structures and the way we save the data um, is also important. When we are trying to build these kinds of systems. What are these kinds of? Google is one of the examples of this information retrieval system. Okay, and we have seen on Friday we have seen this term frequency matrix, that is nothing but bag of words matrix, and Jaccard coefficient, and TF-IDF matrix. How to calculate a TF-IDF score. Now, weighted term frequency is called as term frequency in TF-IDF. What is weighted term frequency? With the increase in the number of occurrences of a term in a document, the importance will not increase. The importance is not directly proportional to the number of occurrences of a term in a document. So you apply log, it actually nullifies when beyond certain limit, the importance of the term in a document will reduce. So we are actually using a mathematical formula to nullify that and create a weighted term frequency. And we are calculating inverse document frequency, which is nothing but how many times a term occurred in total data, right? So how many documents, sorry, a term occurred how many times in how many documents in a data set, in a corpus, right? So if there are 10,000 or 1 million documents, maximum DF, document frequency is going to be 1 million. So even if the word occurred 100 times, we'll take only one occurrence, right? One as the count, that whether the term is present in document or not. That's what we are trying to see here. And we are calculating a log formula where the maximum a term occurring in maximum documents will get less score. Example, if all 1 million documents has got one term like is or that or this or kind of stop word, then the inverse document frequency will become 0 because DF is equal to 1 million, N is also 1 million, total number of documents. So log 1 base 10 is going to be 0. Right? So this way we are giving less score to the stop words kind of a thing, and then we multiply this with the term frequency, which actually makes the two frequently occurring words in too many documents. The terms occurring in too many documents and too frequently occurring words will get 0, a score near to 0. Even if you forget to remove the stop words, and even there are terms which are not stop words but still not important, right, they'll get nullified. In this process, you may actually nullify the important words also, but most of the times it works positively. Positively in the sense, the terms which are not important occurring in many documents or spam documents will get less score. Spam documents, which will try to produce content to make the document come in the first page of Google, right? Or wherever you search, it tries to come as the first document. So those kinds of spam document scores will go low. So that is TF-IDEA score. So I kind of showed important ones first, and to get a gist of what we are trying to do. But now, right, today we'll see other approaches also. There are in information retrieval, there are other approaches to retrieve information. So spelling correction is one of the information retrieval. Why we say spelling correction is one of the information retrieval? Because you type a word important, right? So I spelled E as A as E, and Google is showing it as a important, right? So it is actually retrieving information, right? There are many words which are close to important. It would have taken all those words, and then it would have searched the space and found the correct word and trying to show. So we are retrieving information. So this is also information retrieval only, right? So there are algorithms like SoundX. This is an old algorithm which is not used, but it is an interesting one, so I kept it here. So SoundX algorithm was used in way back, like maybe 5-10 years back. In the Oracle, Oracle database they used to use. Okay. So SoundX algorithm will try to take any word and try to reduce it to 4 characters. Right? If there are Herman and there is another word, I think Herman, MMAN. Where is that? Give me 1 second. Let me try to. Yeah, this one, right? So this word and this word are actually sounding same. Herman, Herman, right? Double M is there. Here only one M is there, right? If you want to stress it, a little more stress you can give. Now similar sounding words will get a same 4-character form. When you apply SoundX algorithm and take a word or take 2 words which are sounding similar, you try to apply this algorithm, you will get 4-character words out of this one and this one. Both will be same, right? That means the words are words may be similar. That's the algorithm's main goal of reducing it to 4 characters. So did you get it? Can I move on and explain? Did you get why the SoundX algorithm and how it works, or what is it doing? What is it doing? Ultimately, SoundX algorithm will reduce every word to a 4-character form. If words are sounding similar, they'll get same 4-character form. That's the thing, right? So if you take Herman, right, and then this is the algorithm. Retain first letter of the word. So it retains the first letter of the word. H will not be touched. Okay, and then change all occurrences of A, E, I, O, U, H, W, Y to 0. First character it will not touch, but these characters will be converted to 0. So it found some of them, so it converted them to 0. So the process of converting a string into 4-character form is what we are doing now. Change letters to digits as follows. If B, F, P, V comes, right, we will convert it to 1. C, G, J, K, right, to 2, like that. Okay. M, N, it will convert to 5. So there is her, M and N, both are there. So it converted to 5. And then R comes, it's going to be 6. Remove all pairs of digits. If there are 2 zeros, 2 fives, 2 sixes like that, right? It will remove. So then remove all zeros. Right? If resultant string is more than 4 characters, right? Then truncate, right? If you know, fortunately we got 4 characters only. If we have more characters, right, it will truncate it to 4 characters. If less than 4 characters, add zeros there. So that's the ultimate result. So Herman actually converted to H655. If you take this one, right, double M N also, it will come to 655 only. So that way, the SoundX algorithm is trying to find closest words. Why do you need to find closest words? Somebody would have typed something wrong in the search query, right? We have to correct it and show, right? In a Google kind of a information retrieval website, you may have to show it. Got it? Any questions?
Please.
Okay. Now, right? So where will we use, right? Correct the documents with spelling mistakes. This is one place where the these spelling correction algorithms are used. And okay. Yeah, when you are doing document search, right, it may not be right because you cannot correct the spellings inside the document, but you can correct this, spelling in the query. Okay, when the query was wrong, you can correct it and appropriate documents you can find. Correct the spelling mistake in user query to retrieve right answer. Okay, this is where spelling correction is used. Spelling correction comes under information retrieval concept, and there is a concept called as noisy channel correction, which I did not cover, but you can go to. I'll show you the resource to actually understand the concept. So that is used in language translation models and other language generation models. Okay, so let us look at this whatever we have right now. So isolated words, right? There are two ways of spelling correction. Isolated word spelling correction. If only one word is typed, you are going to find the appropriate word in the dictionary or closest word in the dictionary and try to show whether that is the spelling the user is trying to type. Okay, that is isolated spelling correction. There is context sensitive spelling correction. See this: I flew from Hyderabad to Bangalore. This farm word will be present in dictionary, right? But if you look at the whole sentence, will that match? Will the farm correct spelling? Guys, if you look at whole sentence, will the farm the correct word?
No, sir.
So it's a typo error, right? From
Correct.
written as farm, right? So system should look at the whole context and then try to correct the spelling. So two ways of spelling correction: isolated and context sensitive. So we look at isolated first and then we look into context sensitive. Now context sensitive spelling corrections are very useful in the OCR. Right? OCR is optical character recognition. A document, right, a PDF or an image, right? The PDF that is having image or an image, you want to extract text from it, that is called as optical character recognition. So the example I can say is we built a speed detection system where we were capturing the number plate, right? The image of the number plate. From that we were extracting the number, right? So we built a object detection and extraction model there to do the number plate extraction. So that is OCR. So we will see in deep learning how to build our own custom OCR model. There are packages like Tesseract if you still want, if you want to experiment, right? So Tesseract, this is a OCR component. This is open source one, okay? But the guys like AWS and Google have actually funded this project, and they improved on top of this, and then they are providing a cloud-based service. So I think open source is another gambling that is happening in the software industry. If you look at MySQL or the Tesseract kind of modules, these big companies fund them, and the research happens. Many people contribute. At one point in time, it's an open source thing, right? And they take the code, they improve on it, and then they sell, right? So that's kind of stealing people's intelligence, right? Open source, the people will be thinking that it's open source. Other people will use it and they contribute, and these guys will actually take it and use it. This Tesseract model will not work that good, but OCR model built by the Google or AWS works better because they took this people's work and they improved on it. Okay, so OCR, right? When you are doing OCR, D and O will be read as one. R N, if they are both next to each other, it will be read as M. Okay, did you get the problem with OCR? So ultimately, after retrieving the word, we don't know whether it is RN or M. So we need to find out the closest word in the dictionary and try to show the suggestions. Our most appropriate using probabilistic model, we may have to find out most appropriate word and replace it. Or we may have to build a context sensitive word like this and then see whether it makes sense or not. Got it? How will you do it? In language models, I'll show. I'll actually explain the theory of how exactly we do. If you have any questions here, I can answer even now also. Any questions on this context sensitive search? No? All are not joining. I don't know why. These are very important concepts. NLP and computer vision are the problems industry want solutions for, and there are literally no people I am saying, because out of 1,000 people who know AI, only maybe 10 to 20 people can actually do NLP and deep learning. So you need to engulf these concepts a little bit, then you will understand why and how we can solve it. Okay, I'm telling this with experience. I have trained around 300 people. Out of those 300 people, only handful, like maybe 5-6 people know NLP and deep learning. In the industry, who are working also don't know. Only 4 to 5 people who know and who can do. So that's how the industry is. Now I am trying to dump very intense content, but still people are not getting it. If you take the people from other institutions, right, you can imagine how they are going to be, right? If somebody is intelligent by themselves, right, they'll know. But I'm not counting that. According to our current whatever output, right, only handful are there, because by this time people will get exhausted. Right? We have heard many concepts. By now, everybody is exhausted, right? So when will this course will be completed? Like that, it is going to be. But this is the important thing. So we have learned all the fundamentals, and we are out trying to apply now. People are not attending classes. That I don't know. So any questions here?
No, sir.
Okay. So we will anyway come to this OCR thing, and I'll explain you. But the point I was trying to make is, if
Okay, my mic is mute. Sir, my mic is mute. Sir, OCR at TIFF format, only TIFF format we need to convert all the OCR documents, or any
no,
form?
not only TIFF format. PDF will also have
PDF
image.
also, okay. Okay.
PDF will have, and normal JPGs, PNGs.
PNS. Okay, okay.
Any
Any
image
format,
PNG.
any kind of format we can. Okay.
Yes, and yes, sir. We can extract text out of it.
Okay.
I am actually trying to find a word that is like, that's having RN in it, or and the way we do spelling correction is based out of language models as well as the information retrieval also. Okay, so I think maybe I'm going into details of it, but let me explain for maybe 1-2 minutes. Suppose that I did OCR. There is no RN or anything like that, right? But I did some OCR, and I have got. I flew from Hyderabad to Bangalore. Okay, this is the kind of sentence I got from OCR. Suppose that after extracting text, I got this. So now, right, I need to see whether this is correct sentence or not, right? To do that, what I can do is I can take the whole sentence and see in the database or in the corpus how many times this whole sentence occurred. Okay, so I flew from Hyderabad to Bangalore. How many times this sentence occurred in the database? Will we find this sentence in the database? In the database, in the sense you have Google kind of database. You scrape the whole world and you have Google kind of database. Can I find this kind of word in the database? Sentence.
So there is a chance, sir.
Farm. Is there a chance? Right.
Okay,
I
okay,
to
okay.
farm. Right. It's a spelling mistake, right?
Spelling mistake, yes, yes.
Yeah. There is a chance, but it is very rare. Maybe out of 1 billion, you may find one or two. Right. One or two documents, or maybe 10 documents. Okay. But now you can change you know that this is a location, right? This is a geographical location. This is a geographic location. Change these geographic locations to some tags, right? Geographic location. Take the database, change all the geographic locations with geo, some tag. Okay. So I flew from geo to geo. Got it? I changed the database in such a way that I flew from geo to geo, some place to another place. Okay. So now you try to search, you may find more probable, right? It may be more prominent. Out of 1 billion, maybe 100 will come, but still it is not right because farm, right? It is not right. So now to check whether this whole sentence is correct or not, as a human being, I know that farm is not a appropriate word in this particular sentence, but system doesn't know because the computer always looks at text as numbers or mathematical or some probabilistic approach, right? So now the third thing what I'll do is I'll change this I to some, or try to find the closest words to I, replace it, and try to search we, maybe there is no closest word to I, so I'll keep I there. There it is, and flew I'll change it as flee, FLE, right? That's the closest word, right? I flee from Hyderabad to Bangalore, or geo to geo. Okay. Now I will search the probability. It may increase, it may decrease. I'll keep that aside, right? All the closest word to flew will take and replace and try to see the probability. Okay. And then for from, I'll change all the closest words. From I'll put and change it and geo to geo. Then the probability will increase, right? If I flew from geo to geo, now I look at the database and try to look at the probability, right? Out of billion times, it would have been 10,000 times or so. Geo to geo, not Hyderabad to Bangalore, not specific, generic locations. Now I know that the from is the proper word. After OCR, you may get wrong characters in the words, but you actually try to take the data and find out each word's closest word and then try to replace them, right? This is how the language translation models will work. When you pass a Italian sentence to a language model, you got an English sentence. After getting the English sentence, right, it will actually go to information retrieval system and try to check all the combinations and see which one is the most probable one, and that one will be outputted. Speech to text systems also. You talk, system will try to understand and try to generate some sentence. After that, it will take each word and try to see contextually whether that word makes sense or not by looking at probabilistic model, language model we call it as, and then ultimately retrieves the sentence which is more prominent according to the data. Got it? That's the application of sentence, context sensitive spelling correction. Got it? Any questions? Any questions, concerns?
No, sir.
Clear, sir.
Yeah, good. So we know the application now, right? So spelling correction by Google or language translation or speech to text systems will internally use it. Do we need to build it? No, we cannot. No, basically we cannot, because huge volume of data is needed as a corpus to check against the words we get. So it is always good to depend on these for speech recognition, language translation kind of models. It is always good to depend on the cloud based tools like Google ML, Azure ML, or AWS SageMaker. Right? They have got huge volumes of data there. Right? Google is the best one, I would say. Google and Azure. Next comes the Amazon, the SageMaker. Right? They have huge volumes of data with them, and they built the models, and they have huge systems, the computers, supercomputers kind of thing they have. So the training would have happened better. So the understanding is better. And on top of those, their models, right? They gave us facility to train on our data. It is called as transfer learning. They would have trained on billion, corpus data set. We have maybe 100 documents. We can actually train using our data, and it will perform better on our data. Okay, our domain and data may be different, right? So if time permits, right, I'll show. Rather, you will get it. How to use it and all. You will all anyway get it. Okay. So isolated word spelling correction. There are 3 ways to do that. Edit distance is one approach.
Sir, 1 second, sir. So you mentioned that we can make use of Google or Amazon, those models. Uh, is it free models available or?
No free models, sir. Sorry. They are paid. Let me show you.
Okay.
Let me show you one. So we are doing some language translation research, and there are around around 100 different modules which can do language translation, like Google, Index, Azure ML, Sogo. These are all Chinese stuff, right? So DeepL, all these are. But Google is supporting 108 languages, maybe more than that now, right? And they're paid. See this? Azure ML up to 2 million characters is free, right? Approximately 400 to maybe 1000 pages, right? And then beyond that, right, 660 rupees per million characters. Okay, a standard translation, custom translation, right? This is the you want to train your model and try to use it, then you have to pay more. Okay, right? Like this, so for Azure, for some extent it is free, and Google also language translation up to 0.5 million it is free. Beyond that, every 500,000 characters it's going to be $20, like that it is. Okay. So when you go to that API and look at the pricing, right, you will see all that information, and they'll give $300 credit. My credit is over. I actually tried some some concept there and forgot to deactivate it. and in 2 months automatically it got over, right? If you don't use it also, there will be days limit and usage limit also. So within that stipulated period, you should be using those $300, rather it will expire. Okay, so when you have real use case and you want to really work on it, then only activate that. Any email ID, any Gmail ID, you can activate it and use it. Okay. So there are three ways of doing isolated spelling correction: edit distance, weighted edit distance, and n-gram overlap. Jaccard coefficient, we already seen it. Right? So let me start with Jaccard coefficient. Right? We already have seen it, right? So I wanted to, if the important spelling is wrong, instead of A, if I have E here, I would have taken all the words which were having 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 or 10 characters, right? And then all which are all starting with I would have taken. That way I'll reduce the search space. And now I'll take a trigram overlap of this word and all those other words. And if the spelling is wrong, I would have got important, the highest score. I would have taken important and would have showed that as the suggestion. Right? If its spelling is correct, I will get exact thing. No need to show any correction. Okay, that way the Jaccard coefficient will work. Got it? Spelling correction, Jaccard coefficient, how to use. Okay, rank retrieval model only, right? Whether you use it for, in rank retrieval model, what we are doing, we are taking the query string and trying to take the Jaccard coefficient of query string with the documents, whichever is giving high, you are retrieving it and showing it. But in spelling correction, right, you will see whether the word typed is present in the dictionary or not. If word is present in the dictionary, you pull out and show, or the word is exactly matching with the dictionary, you will not show anything. If it is not matching, then you bring it out and show. Right? This is isolated. In this case, right, I flew from Hyderabad to Bangalore. The Jaccard coefficient isolated spelling correction will say that there is no mistake. But in a context sensitive thing, right, it's a mistake. I'll show how context sensitive thing works in a moment. Right? Edit distance and weighted edit distance are also two metrics. Do we need to build all this? No. We have methods like Jaccard coefficient. We have methods to do edit distance and Jaccard coefficient and all that. Okay. We need to understand how exactly it is working internally. Okay. So the edit distance uses a concept called as dynamic programming. There is no programming involved in there. It is just the guy actually named it very fancy to make it popular, so that people will concentrate and see what it is. Right? Dynamic programming is a mathematical formula. This is dynamic programming. Okay, this is dynamic programming. Got it? So how it works and how it finds, right? We'll see that. So if you take this, I have taken these slides and this whole notes from Zurevsky's notes. Dan Zurevsky and Manning are the professors from Stanford. So these are the videos actually, right? This guy is Dan Zurevsky, and this guy is Manning, right? I never understood this guy's class. He speaks all simple things as big, as a very big thing. Right? I never understood this guy, but this guy is straightforward. If you have time, right, try to watch these videos. There are many. If you go to this,
what is machine learning?
so this is the playlist. Okay, Stanford University. So there is a new. I think I'll copy this and paste it. Artificial intelligence all in one. Text mining and analytics. This is the information retrieval concept. These are the right. So, yeah, I'll put it into chat. If you guys are interested, you can use it. Right? No need to really watch it, but if you have time, you can watch it. We are covering most of it, 95% of it, I would say. So these guys' notes, I actually tried to take. If you want to see that intuition is close to execution, if you want to see whether intention, the word, is close to execution, what you do is you try to transform this intention to execution by deleting some characters and replacing some characters. Okay, right? So, and using the same characters. If intention and intention need to be replaced, both words are same, then no deletion will happen, no replacement will happen, right? So if you are using the same character, you will give 0 score. If you are actually doing a deletion or replacement, you will give 1 as the score. Okay, so how many deletions replacements happened, that much bigger score you get. Minimal the score of transforming one word to another, they are close to each other. Okay, edit distance, you are trying to edit this into this and trying to see how much distance it is, right? Intention you took, you are trying to edit intention and trying to change, make it as execution, and how much distance is 5. Intention to intention, 0 you'll get. So I deleted D, replaced N with E, T with X, E used it as E, and in the created a space and kept C, right? Inserted, right? Insertion, deletion, and replacement are the 3 operations. Right, replaced N to R. I have got for each deletion replacement I have got 1 score. The total score is 5. Right? So how do I know that I have to delete this? I need to replace this. I need to insert this here. That will be calculated using edit distance, the dynamic programming, this math. That is the shortest path to change intention to execution. Got it? What is edit distance and what is dynamic programming? Any questions? Okay. So now we will see how exactly this, how do I know that I need to be deleted, N need to be replaced, T need to be replaced, C should be inserted. This whole thing is calculated using this dynamic programming concept. So we'll see how exactly it is. It is actually progressing and finding. Even if you don't understand, don't be worried, because out of my finicky nature, I am trying to explain. So if somebody is interested, they'll know it, right? So there will be initial state, there will be operations, insert, delete, and replace, and there will be goal state, execution. We are trying to find out the distance between intention and execution. In order to find the distance, we are going to transform intention to execution and see how far it is from one from the other. Okay, how far one from the other. The path, the number, the path cost, the number of edits to transform initial state to goal state. That's the right. The algorithm will try to reduce the path cost. Okay, so it will find the best path that actually takes less cost. Okay, so first of all we need to see this matrix, distance matrix, right? Y0 to ym, x0 to xn. Okay, so x is the initial state. I am taking x on the y-axis, right? I should have taken it in a reverse order basically, right? Y. Okay, that's okay. So x on the y-axis I have taken and y on the x-axis. It's a reverse thing. Okay, so y is the target state. Okay, so we'll see what this is actually. Then dij is the edit distance between x1 to I and x1 to j. So if I take some point somewhere here and some point somewhere here, there will be characters. Like these are all characters and these are all characters. From here to here, sorry, this is from here to here, to translate it to transform this to here, how much cost will be shown by that cell. Okay, So let me show you that example. See here, the intention and the execution. If you look at this number 5, what it shows is INTE to transform it to EXE, it takes 5 as the cost. INT here I have taken the Levenstein's edit distance, right? So in Levenstein's edit distance, replace takes 2. In the diagram, right? I showed replace is equal to 1 here, right? When I replace it to 2, right here. So here 2, here 2, here 2, 6 plus 2 is 8. Got it? If you say Levenstein's edit distance, it's going to be 8. That is called as weighted edit distance. For replacement, we are giving some score. For insert, we are giving some score, and delete, we are giving another score. Right? If you go even further, right, for some characters to replace from one to another, the edit distance is going to be more. For some characters, it's going to be less. That is weighted edit distance. Okay. Got it? Any questions there? No, right? Okay. So I am taking Levenstein's edit distance. That's where now to replace or transform INTE to EXE, it took 5. But INTEN intention to execution, maximum it will take 8 if you take this path. Okay. So replacement insert, that will actually show you, right? If it is flat, right, it is insertion. If it is growing, right, then it is going to be uh, replacement or deletion kind of thing. We'll talk about that. So in here, let me take. So how this formula works, I'll actually try to show. One second. Give me 1 second. So here, so what is I, what is J, we should know first, right? So if you look at, if we look at, so on the y-axis it is I, on the x-axis it is J, okay? On the x-axis it is J, and on the y-axis it is I, okay? So here we need to calculate the score. Okay, to calculate the score, we'll use this formula, right? Minimum of D, I minus 1 and J, right? So here we will, there are numbers assigned, right? Initially, for this hash row and hash column, there will be numbers assigned. Right? Those are the edit distances, default edit distances. Using those numbers, you calculate. So I need to calculate this one, right? What is that D? What is the I here? What is I? I value? What is the I value? X on here, Y on here. What is the I value? I is in this direction, J is in this direction. Right? So I value is 1, right? Do you agree?
Yes, sir.
Right. So I need to calculate this one, right? I minus 1 comma J. It is 1 minus 1 is 0 and J is how much? 1. Right? This is J. Okay. This is 1. Right? Plus 1. D 0 comma 1, right? 0 is this one. Sorry. 0, 1, right? D0, 1 is 1, right? This value is 1. So 1 plus 1 is equal to 2. Got it? Got it? D0, comma 1 is 1, right? This is the 0th row, right? And this is the first column, right? The corresponding value is 1. Okay, plus 1 is equal to 2, right? So out of these three formulas, we calculate one formula now. The second formula we need to calculate is D I comma j minus 1. I is 1, j is 1, 1 minus 1 is 0, plus 1. So how much? D1 comma 0 is what? D1 is D1 is this first row, right? And 0th column. Right? First row 0th column is what? 0 plus 1 is equal to 1, right? And then the third formula we need to calculate di minus 1 comma j minus 1, 0 comma 0, right? I is 1 and j is also 1 here, right? I is 1, yeah, I is 1 and j is also 1. So now 0 comma 0 plus if it is if si is not equal to sj, right? S1 I is the string 1's, right? String 1 is this one x, this is string 1, this is string 2. String 1's I is not equal to string 1's j, right? String 1's I is what? String 1's I is what? S1 of 1, S1 of 1 is what? I, right? S2 of 1 is E. They are not equal. So you need to put 2, right? That is a replacement score. We are using Levenstein, so we are putting 2. If it is not Levenstein, we would have put 1 there. Okay, so this is 2. So D0 comma 0, 0th row and 0th column is 0 value, right? 0 plus 2 is equal to 2. So minimum of these three will take, okay? Di comma j minus 1, I is 1 and j minus 1 is 0, 1, j minus 1. And this is also 1, right? D1, D10 is how much? D10, first row and 0th column is this one, right? 1 right here. This is 2, right? Minimum of these three is the ultimate score we need to put. Minimum of those three is the ultimate score. So we'll get 2 here. Let us see whether we calculated correctly or not. See that I calculated correctly only. So here it is 2, right? Got it? So that's how we this edit distance formula is used. Okay, if I have to now, right, will we move in this direction or this direction? That also we need to see, right? So here, if you look at this for loop, for each I is equal to 1 to m. What is m? This one. Oh my god. Yeah, for each I 1 to m. For j 1 to n. Yeah, fortunately we got it right, but yeah, I think I showed you in a wrong direction, but the formula, right? If you look at this, right, this first for loop is about the y value, the target string. The second value j is about the input string. I actually kept it wrong. This is j and this is I. Fortunately, we got the calculation right, but that's okay, right? So the next step is going to calculate this value. How did I say? When you look at this, right? So it is doing for I1, it took 1, and then from J1 to N it is going, right? So it took this value I, right? And then this is J, this is I, and this is J. So then it is going to take 1, 2, 3, 4, 5, and all it will calculate. Again it will come to 2, and again it will do 1, 2, 3, 4, 1, 2, 3, 4, like that. Got it? So next value will be calculated here, next will be here, next will be here, like that, and then it will calculate here, 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 like that. It will calculate the values and find out the path, best path to move from one place to another. Okay, if you look at this, right, this is this is ultimately we are getting 8 as the edit distance. Okay, and we can know that here um, um, there is a score here, so we need to delete, and then we need to here replace. Here we will know that whole score 1 plus 2 is the 1 is the delete, plus 2 is the replacement, plus 2 is the replacement, and then there is no no change in the score. That means same character will stay, right? These characters are same, E and E, right? And then it is actually flat. That means we can use the same, and again 2 score, that means replacement, no change, no change, no change, no change, right? Like that it is, no change, no change, right? So that is edit distance, and how that whole calculation happens. Do I need to do or understand all this? No, edit distance formula is already implemented in our modules, right? NLTK it is there, and scikit-learn also it is there. You can use that, and you use that and find out whether a word is close to other word or not. Context insensitive or the isolated spelling correction we can do. Okay, so this is dynamic programming. This whole formula, whatever I used here, right, that is called as dynamic programming. Got it? I wanted to explain what is dynamic programming, because there will be articles written on these things, and it is waste of time. No need to understand how exactly it is calculated, because anyway it is already implemented. Okay, got it? Any questions there? Any questions? Okay, so weighted edit distance, no? For insert there will be different score, and delete there will be different score, and replace there will be different score. While using this dynamic programming formula, I was actually for delete this formula, for insert this formula, and for replacement this formula. Whichever is minimal, we'll do that. Okay, okay. The delete will take or insert will take more than replacement. We'll do replacement only. So depending the weighted edit distance for different characters, you can assign different scores also. Okay, that is weighted edit distance. Jaccard coefficient we already have seen, and then context sensitive search. Right, previously we were talking about context insensitive search, right, or isolated spelling correction. Now context sensitive search. Flew from Hyderabad. This sentence is wrong, we know, right? So how does the computer understand whether it is wrong or right? Okay, so what it will do is first take the individual words like this: flew from Hyderabad, and then lexicon is nothing but the dictionary words, right? The query log, right? The previous queries all will be saved by Google or somebody, right? And it will create a dictionary. What is dictionary? It is not English dictionary. Whatever distinct words are coming from this, it will keep it here. Okay, and then it will try to look at individual words, closest words, or using edit distance, right? It will try to find, take this word, pull out all the words which are close. Right? There will be some threshold it will keep, and it found the closest words for flew is flew, fled, and flee. Okay, it took and kept it. And for farm, it found from, farm, forum. It kept it. For Hyderabad, it found only Hyderabad. Okay. Now what it will do is it will do combination of all these. Right. Flew from Hyderabad, first combination. Flew, farm, Hyderabad, right? There are other combinations here. I am not showing the proper combination and other combinations. Flu, forum, Hyderabad. It will form those combinations and try to see how many times a combination occurred in the query log. This one occurred one time. These are all occurred 0 times. So this is the most probable correct spelling, correct sentence the user would have typed. So we did spelling correction context sensitively. Did you get it? Got it? Any questions there?
Yes.
Okay. So, it is probabilistic model, right? It is ultimately probabilistic. So it is actually taking all the combinations and trying to see which combination is most present in the data. If query log is small, you will get all wrong results. If query log is huge, you will get good results. That's where I said we may not be able to build spelling correction models on our own. Okay. So, if you don't know this, how internally it is working, to a client, you may say, right, I can build a spelling correction and speech correction and all that. No, we cannot. We should be using the pre-existing models only. Even if you try to do it, it will take 2 years. It may become a research project, and by the time there will be many tools out there in the market, and the client will lose the business. Got it? So it is always good to use cloud-based solutions for speech recognition, spelling correction, and even OCR, right? Optical character recognition also. Okay. So for some extent, for some problems, optical character recognition can be done. The example is the number plate recognition, because in a number plate, there will not be many fonts, right? Most recently, the government released a rule that in India, we should be using Arial font only, right? Only one font. You take all those pictures, right? Maybe 10 to maybe if you really have access to public traffic, right? You can get 10,000 or maybe 20,000 images in a month. You collect it, you label it, you build a model, and it works. But if you want to build a OCR for PDFs, we cannot do it. Right? The documents built by are written by some for some analysts or the Google News kind of a thing, you cannot do it because it's very tedious to collect all those fonts and doing that OCR stuff. Okay. So for some problems, very rarely we can build our own models, but many problems it is always suggestible to use cloud-based solutions for these kinds of problems. The spelling corrections, speech recognition, language translation, speech to text, these problems. Okay. So this is actually, right, this is actually a tedious process. If you look at this, if you have too many lexicon for a word, right, it will have more combinations. And again, you need to actually see whether that combination occurred in the query log or not, right, to calculate probability or the count, right. So we can reduce this, the search space or the combinations by intelligently doing it. Let us look at that next approach, right. Instead of taking all combinations, what I'll do is I'll take flew from, right, and then I'll take the first word and take the first closest word and take the second word, take the maybe first two closest words and form combinations and try to see whether this combination is occurring in the query log or not. If this occurred, I'll take that and try to combine with the third one and try to see whether that is occurring or not. Instead of doing this many searches through the data, we are actually reducing the search space. Got it? So instead of taking all combinations, taking only few combinations and trying to see first combination is hitting or not. We call it as hits, right? Hit 1, hit 2, hit 3, right? What is hit 1? Hit 1 is going to be like, right, how many times this particular, from dictionary, definitely there will be hit. Dictionary is correct, actually formed using the query log data only. So you'll have hits here, but many hits, right, which are actually occurring more times. We'll try to form combinations with them, and then those combinations are present or not, we'll see, and then we try to take the last word or whatever word, next word, and try to form and again see whether that whole combination is occurring or not. This way we'll reduce number of searches and it will be faster. Context sensitive search is going to be faster. So spelling correction we did here. Okay, this may be after OCR or maybe after language translation or maybe after speech to text. Before this particular model, there is a model that is doing either one of these applications. Got it? The complexity involved in building these kinds of things we need to understand. Okay, got it?
Yes.
Okay. So I'll stop here, and again, tomorrow we'll talk about rank retrieval model a little bit in detail, because there are different ways of calculating TF-IDF score. I'll show you, and then we'll talk about the other ways of finding the distance between vectors, or rank calculation. Cosine similarity is one more concept used in many places. Okay, so we need to understand. Even in image search, also the cosine similarity is used. So we'll understand these two concepts tomorrow. With that, right, I'll conclude information retrieval, and we'll jump into topic modeling. Right, that's also a machine learning approach only. The SVD, singular value decomposition based text summarization, we call it. It may not work that good, but industry is using it, or interviews people are asking. And then we'll jump into deep learning. So tomorrow, day after tomorrow, from Thursday, we'll be into deep learning. Okay.